Good evening. In this lecture, we are going to cover mechanical vibration, logarithmic, um, logarithmic decrement method in half bend, with which is also called the half power point. Okay, so we have these two methods. The first one is this one, the logarithmic decrement, and another one half bend. So first, we will go for the logarithmic decrement to measure how to measure the damping ratio, and then we have to go for the second one, the half width bandwidth. Okay, so let's go with this one. Basically, we have to start from here. It's like we have the vibration, and logarithmic decrement, it's mean that exponentially decreasing from the starting point. Like we have the starting point here, it's like exponentially decreasing until here with the passage of time, and we are starting from zero, and this is the magnitude with respect to t, and this one is basically the one cycle which is completed by, we can denote it by t, and from here to here we can denote it by the x1. In here we can denote it by the x2. So this is x1, this is x2, and we have to mirror the from t1 to t2. It's like from t1 to time 1 to time 2 is from here, it's from 0 to t1, then from t1 to t2. Okay, so this is what we have, the one cycle. So we know that actually t is equal to 2 pi and divided by damping natural frequency. Okay, so now what we have, what we know more about this. So this is basically for undamping, for undamped system. Okay, sorry, it's not for undamped, it's for underdamped system. Okay, it's for underdamped system, because if there is no damping, this means there is no decrements. Okay, so we have equation for this one with respect to xt. It's like t equal to this magnitude, of course, and this is e rho, or you can call it zeta, natural frequency to t. Okay, so this is cos damping frequency with respect to t minus theta. Okay, so we have assumed that, not assume actually, this is t1 is equal to t2. If we want to reach here, we need to consider the t1 from here to here plus t this one. So in here we can say that t2 is equal to t1 plus t. This is, we have the relationship. Okay, so let's consider this one and put this equation into the extended one. Okay, now we want to calculate this. Actually, we want to know this x1, x2, x1, x2. So let's divide x1 by x2. Okay, if we want to divide it, we have to write down these equations, the entire equation again. Okay, and this cosecant is t1, because this is for the x1, so it's t1, and then again, but here we, for x2 we have this one, for x2 we have the t2, so t2 is equal to t1 plus t2. So in here we have to consider the t1 plus t. Okay, the capital T. So this is what we have, a cosecant, then we have to add here as well. Okay, t1 plus t and minus this. Okay, so basically for we are going to calculate, for one cycle. Okay, cool. So we know that from trigonometry that cosecant and wt, which is t1 plus t is minus theta, is equal to cosecant t t1 minus this plus 2 phi, because this is for one cycle, so one cycle is 2 phi, is phi is equal to in 180. Okay, so it's like 360. Okay, cool. So and since we know that sine theta is equal to sine theta plus 360, so when we have this 360, this is angle theta. Okay, so we can write that sine theta instead of this, or if you don't understand, then we have to go for this one. Okay, and so from here we can put this one, or you can see theta cos theta plus 360, so it's also equal to this. So here we have to x1 x2. Basically, when I was learning these things, these steps were not explained, so I was got confused, and I try my best to solve it for you people so that you can easily understand these things. So okay, this one we have to write these terms again, cos in this is wdt minus this one, and then we have this 2. So because when you add the basement, the base, you have to multiply, you have to, when you multiply the base, you have to add the superscript. Okay, so we have this wt1 wn capital T. Okay, good. So we have cos wd as per this one. So we have this one, then we can cross multiplication, we can cross out this one, and then we can cross out this one. So x1 is equal to x2, and then we have, it's in basement, so when we take it to the above level, this minus became plus, so wn is equal to t. Okay, so we have this one. So far we have this one. Okay, then we want to, define um, uh, okay, decrement. We have to start with the define this one. Okay, logarithmic decrement denoted by this one, and then we have to apply the log x1 x2 apply on both sides. So when log apply with the exponential, so it's become, as per the trigonometry, it's equal to it's cross out, so we have this, and with this one, as we know that we have that Wt is equal to Wn, which is natural frequency, temp frequency, and 1 is 2. Okay, so by putting all these things, we can do 2 phi. Okay, Wn1 is 2, so it's cross out, cancel out. Okay, and then we have logarithmic decrement, sorry, 2 phi in 1. Okay, so in from here, um, by expanding and arranging, we have this 1 phi. Okay, and then 2 phi. So the final equation is, when expanding again, zeta, which is damping ratio, with like logarithmic. Okay, I'm sorry, 2 phi square plus those. So what does it mean? It mean that this is which can be used to obtain the damping ratio. It's like how, if we have we can find the logarithmic decrement from x1 x2. So when we find the logarithmic decrement, we can put in here, and then we can get the damping ratio. Okay, so we have some we have some. We need to mention some other things. Just like we have some remarks. It's like this is important. Don't just miss this. Okay, just for 1 minute or 2 minutes. It's like from derivation. So we want from derivation. Okay, we can we can we can use any time. Okay, for which t shouldn't be equal to 0. Okay, uh, t equals so but it's easier to use the peak one. Okay, and the second one, the last one is for v small um, damping ratio that from v small damping ratio, if we can rearrange this one, then the logarithmic uh, decrement will be equal to y this one, because if this is very smaller and you put like 0.00 like this one, so it's become like negligible to the to 0. So it's negligible to 0. It's like then 0 in here. So sorry, we are talking about this one. So when it's equal to 0, um, oh sorry, it's equal to 1, then you can rearrange, and we can see that the this one is equal to this equation. Okay, okay. So uh, basically, when the final one is what if we have we have what if we have more than what if we want to calculate for more than one cycle, like x2, x3, x4? So what we have to do, so basically it's like logarithmic decrement is like this. Okay, then log e is like 1. Okay, then plus log for another cycle 1 by x2, and then go for this. It's like x minus 1 in x and okay. So but we know that for log is log equal to x0 x1 multiply x1 by x2, x2 by x3. So it's goes here and x in. Okay, and this is what we can do. Like for nth logarithmic, we have log e, so it's cancel out, it's like cancel out, and then we have the final one is x in x in. Okay, and then for like for more than one cycle. Okay, so what we can do is like uh, logarithmic decrement, we have to cross multiplications log e divided by n, it's this and x this, or you can do like x minus 1, or this is the final equation that we have to put for them if we want to calculate uh, for more than one cycle. So this is the final equations. Okay, and thank you so much. I think there was so many mistakes I have done, so because I'm also the student. So you can comment me below on this YouTube channel, and if you like it, just subscribe it so that I can make more videos. I'm still learning these things, so I think it will be beneficial for the people. Thank you very much.